Let's look at the equations from previous video and try to figure out how we can solve them in a formal, general way. So first equation we're going to look at is 6x minus 3 equals 21. I'm reminding that what it means, that we're looking for x, which if we multiply that x by 6 and subtract 3, we should get 21. So the standard procedure of handling the equations is to put unknowns on one side of the equality and known things on the other side. So in our case, we have unknown as x. We have 6x, and that should sit on one side, and it's already on one side. It's on the left-hand side of the equation. But then what we want to do, we want to have all the other things like numbers on the other side. And here we have a problem because we have one number 21, which already on the right hand side, but we also have this minus 3 sitting on the left hand side and spoiling our happiness. So what can we do about this minus 3? How can we get rid of this minus 3 so we just have 6x on the left side? Well, if we have an equation, right, we have a formula and we subtracted 3, okay, how we can get rid of this minus 3? Well, it's very simple. We should add it back. So all we need to do is to add 3 to the left hand side. In this case, minus 3 and plus 3 gonna cancel each other and disappear. But here's the important thing about the equations. We can't just add or do something with one side of the equation. You should never do it. If you do anything with one side of the equation, and by anything I mean add a number, subtract a number, multiply by a number, or divide by a number, as long as it's not 0, you should do exactly the same thing to the other side, to the right hand side. So if we added 3 to the left hand side, we should also add 3 to the right hand side. And if we do, we're going to have 6x minus 3 plus 3 equals 21 plus 3. Again, all we did is added 3 to both sides of the equation. We do the same operation on both sides, always. Now, let's simplify. On the left-hand side, we have 6x, but then we have minus 3 plus 3, that's 0, so nothing else. And on the right-hand side, we have 21 plus 3, which is 24. Now, we're basically looking for a number, x, which if we multiply by 6, we get 24. And, if we know multiplication table, we can easily say that that number should be 4. But let's continue going the formal way. And in the formal way, what we have equation for instead of x, we have 6x. We have 6 times more than what we need. So if we have 6 times more than what we need, how we get what we need? Well, the answer is very simple. If we need something 6 times less than what we have, we just simply divide it by 6. And that's it. We had 6x, we divided by 6, we got just 1x. But again, if you remember what I said previously, we never do an operation on just one side of the equation. We always do it on both sides and always do the same thing. So if we divide it by 6 on the left, we have to divide by 6 on the right. And what do we get? On the left, we get 6x divided by 6, which is x. On the right hand side, we get 24 divided by 6, and as you know, this is 4. Okay, we found our answer. Let's look at the next example. 7x minus 3 equals 3x plus 9. Again, what we would like to have first, we would like to have all unknowns on one side. Let's say we want to collect all x's on the left, and we want to collect all the numbers on the right. Now, when we look at x's, we have 7x's on the left, which is fine. It's already where we wanted to have. But then we have those 3 x's on the right. And those 3 x's need to go away. How we get rid of 3 x's? Well, we just need to subtract them. So we want to subtract 3x from the right hand side. Well, all right. But if you remember previous conversation, we cannot do this operation on one side. We have to do the same thing on the other side too. So if you subtracted 3x on the right, you want to subtract the same 3x on the left. And so, what do we have? We have 7x minus 3x minus 3 equals 3x minus 3 plus 9. Now, on the left, we have 7x minus 3x. That is 4x, right? If you take 7x's and took out 3 of them, we got 4x's. Now, we subtract 3 because we had it. And then we have 3x minus 3x. That's 0. It's nothing. And then we have 9. All right. Now we have all x's on one side. We're good there. But we still have numbers on both left and right hand side. So we want to move all the numbers to the right hand side. On the left side we have number minus 3. Well, we need to get rid of it. And the way to get rid of it is before we subtracted 3, now we want to add 3. In this case, they cancel out. Again, we have to do the same thing on the left and on the right. So we're adding 3 on the right too. And what do we have? We get 4x minus 3 plus 3 equals 9 plus 3. And what do we have now? We have 4x on the left, minus 3 and plus 3 cancel out. And on the right we have 9 plus 3, which is 12. And now we have 4x's equals 12. What is 1x? Again, we're going to do it formally. We have 4 times more than we need. To get rid of what we don't need, we divide the left-hand side by 4 to get 1x. So, and again, we have to do the same thing on the right. We're dividing by 4. So on the left, we have just 1x. On the right, we have 12 divided by 4, which is 3. The problem is solved. And let's consider now the next case. If the case is we considered before, we could have just guessed and got the answer. Now the last case is more complicated. In theory, you could guess the right number, but it becomes more complicated. So let's consider this equation. Again, what do we want to do first? Unknowns on one side, knowns on the other side. So let's try to move all x's to the left. Again, it's not necessarily to move them to the left. We could have moved them to the right. In this case, we would have moved numbers to the left. But, well, it's more convenient for us to move x's to the left, actually. So 5x is already on the left-hand side. That's fine. But we have those 3 x's sitting on the right-hand side. Well, what do? we need to get rid of it. So we're subtracting those 3x's. Again, we have to do the same thing on both sides. So we have to subtract 3x on the left-hand side. Now, I would like to mention here that when you say 3x's, so I'm saying minus 3x's, it's not that I'm subtracting something weird and abstract, okay? I'm subtracting a number because, remember, x is a number. We just don't know what this number is yet. We'll know in a few minutes. But we don't know what this, it is a number, but we just don't know it. So when we say 3x, it means there's 3 times that unknown number, which is number. And 3 times a number is a number. So what we're doing here is subtracting 3x, which we're subtracting as number, some number. And we have to do it on both sides at the same time. So we got 5x minus 3x plus 2 equals 3x minus 3x plus 7. Okay, 5x's minus 3x's, it's 2x's, right? We had 5 things and we subtracted 2 of them. We subtracted 3 of them, we got 2. Now we still have this plus 2 sitting on the left side. On the right side, x has disappeared, and all we have is 7. Now all x's now on the left. Now we need to move all the numbers to the right. So what it means, we need to get rid of this plus 2 sitting on the left. And to get rid of 2 is to subtract it. We want to subtract 2 to get rid of it. Again, we have to do the same thing on the right, what we just did on the left. So we're subtracting 2 from the right side too. And we got 2x plus 2 minus 2 equals 7 minus 2, which is 2x equals 5. All right? Now, what we do, we have 2 x's on the left, but we need just 1. We need half of what we have. How to get a half? Well, we need to divide by half. But again, what we do on the left, we should do the same thing on the right. So we're dividing by 2 here. So on the left now we have 2x divided by 2, which is just 1x. On the right we have 5 halves. You can write 2.5, or you can write 2.5. Whatever you feel like it. But that's it for this video. In the next video we are gonna look at more complicated equations. But the ideas we discussed so far, they're all gonna work there. I'll see you then.